Hi, this is Billy. Um, we talked about if statements last time. This time I'd like to talk about switch statements. A switch statement is similar to an if statement, except you can kind of think of it as shorthand in a way. So the switch syntax looks like this. Of course, I think this is supposed to be a lowercase s, but it looks like this where you have switch and then you have some variable name. And then you have your squiggly bracket here. Then you have case, the keyword case, and then a value here. And then you have a body of statements that get executed if the variable is equal to this value. This body of statements get executed if the variable is equal to this value, and so on. And then if the variable is equal to none of the values that are in our case statements here, then we execute what's in the default body of statements, which is here. So the best way to look at this, best way to figure this out is to look at an example. So let's do that. Copy and paste this into our compiler. I'm going to make it look a little prettier so that way it's a little easier to read. This is roughly what it would look like. Of course, you can also do something like this, because that way you may have more than one statement here. Maybe you have a print. Maybe you have more than one print statement, like so. And so what happens, let's go through this example. Let's look at it. We're creating a number here. Of course, this could be a letter, it could be a bar. Either would work fine in this case because we're not changing the value of number, so a let is fine. Remember, a let allows the variable to be a constant. It means that this variable can't change. And so what happens then is we've got a variable called numbers equal to 3. We enter the switch statement. Here's our variable number. And if the way to read this is that if number is equal to 1, we execute these statements. It's not equal to 1, so we jump down here to the next case. Number is equal to 2, we print out this, we execute this statement. Since that is not the case, we jump down here and number is equal to 3, so we print out the value of 3, and then we jump out of the switch statement. So I am going to put this statement here after switch so that we know that what gets executed after the switch statement, and I'll put something here so that we see that this is executed before the switch statement. So let's run this and see what happens. Probably going to have to run this more than once. It's been a little while since I've run a statement. Okay, here we go. Like I said, we have our before switch. It prints the value of 3 and then the after switch. So notice that it skips these two because number's not equal to 1 or 2. Then it comes down to 3. Technically, these don't have to be in the same order. I mean, the correct order, 1, 2, 3. It's better if it's that way because it's easier for us to find the value if it's in the correct order. But nothing says that we have to have it that way. Like, for example, we could have case 4. And let's do this. Let's do this. My var is equal to ABC. Now let's just print out the value of my var. Execute this again. It's still going to print out 3. It's going to print out the same thing because we haven't changed this variable here. Let's run it just to verify that. Oh, my var was never mutated. Consider changing my let to constant. Okay, this is just a warning. So that's fine. It goes ahead and executes it anyways, and we get the same result. See, I was a little bit surprised there because I saw this extra code or this extra stuff here, and I was like, oh boy, what did I do? Could have made a typing mistake, could have done anything. But let's change this, and you notice that this isn't in order. We got 1, 2, 4, 3. Like I said, we usually put them in order because then we can easily find like a value of 4 to see if a 4 is in there, whatever. For this example, this isn't very big, but you could actually have, I've seen switch statements that have had hundreds of cases in them. And if it's not in order, you would have to go through and look at each case. Okay, is this what I'm looking for? Is this what I'm looking for? Is this what I'm looking for? But if you put it in order, then you can just jump down where it should be and then put it in, see if it's there, make the adjustments to the code or whatever. So to be, I'm going to run it this way by changing the value of number to 4 so that we can see that this does get executed. But then once this is done, I'm going to switch this around so it is in the proper order. And that is the way we should write the code. So that way it's easier to deal with later. So notice here, before switch, it prints out the value of ABC, which is in my var, and then the after switch. I'm going to make a few things here. I don't like that warning message. And so I'm going to make a few adjustments here. I'm going to move the case down a little bit, and then I'm also going to change this to a let so that this doesn't complain. Maybe just because I'm anal, but that's just what I'm going to do. It's usually good to go ahead and get rid of most of your warnings if you can. It makes it easier to find errors, error messages and stuff if you don't have tons and tons of warnings that show. And usually if it's showing a warning, there's usually a good reason for that. Not always, but almost always. There's a reason why the compiler is complaining. So notice here, I get the same output except for the warning message is gone because I changed the var to a let. And I switched the case around so that this is easier to read. So we go 1, 2, 3, 4. Okay, so we could play around with this, different values. We can try to predict what's going to happen with this being a number equal to 1. This should print out these two. Okay, and I'll let you play around with some different values. One thing I'm going to do is I'm going to show when the default is executed. Notice that note here that number is equal to 5. We don't have a case 5, so it's going to go to the default and execute it. Okay, so it's not 1, 2, or 3. Actually, we could write this as an if statement. We could say if number is equal to 1, print 1, else if number is equal to 2, print 2. As you notice here, the lines of code are about the same, but look at the extra stuff that I'm having to type. If I got to type more, there's a better chance that I'm going to make a mistake, a typing mistake. It's harder to read. You look at this, this is harder to read than what this is. This is nicer to look at. It's easier to figure out what's going on. I can see here case is equal to 1, case is equal to 2, case is equal to 3. I could actually make a mistake here and say not equals. Let's say I make a typo here. And so it may be a little bit harder to find this if somebody did something like this. And if you're looking through, you're quickly looking through this code, you may not notice this. And you say, oh, number is equal to 1, number is equal to 2, number is equal to 3, number is equal to 4. That's a little bit harder to read. It's a little harder to see a mistake like this, where if you write a switch statement like this, it makes it a little easier for us to read. Also, I think the compiler is able to make certain assumptions whenever it sees this. Now, I'm not saying to always write a switch and never use an if statement. I'm not saying that at all. What I am saying though is that depending on what you're trying to do, it may be more appropriate to write an if statement, or it may be more appropriate to write a switch. You'll have to make that decision yourself. Usually it's usually black and white to where it's pretty easy to figure out if you should use an if statement or if you should use a switch. But there is a little bit of gray area as well. If you only had a couple of statements like if number is equal to 1, if number is equal to 2, let's say for example, this isn't too bad if you just had the 2. It may not be that reasonable to write a switch that looks like this. This may be okay, but once you start adding 3 or 4 elements, you may want to start thinking about a switch. But like I said, it just really depends. Let me go back. Let me find my shoot if statements. Here we go. I've shown you an example of an integer. You could also do other types besides integer, anything where you could do like an equals to see that something's equal to something else. So let's look at another example. Let's look at a string example. Copy all of this. Let me move it over. Remember to play around with these examples, not just do what I do, but try maybe some other things, see what works and see what doesn't work. And it didn't copy everything. So let me go back. Okay, didn't get this. Let me copy that again. For some reason, it's being kind of different. Okay. Make it look a little prettier. And it's worth the time to make it look pretty because it's easier to read. And in the code that you write, I will look at how easy it is to read, and I will grade based on if you indent a little bit, if you make it where it looks a little prettier like this than whenever I first copied it, where it was just all over to the side. So what happens here is, notice we've got more than one value. We can do this with a switch statement. We could say switch string, and it'll look at this and say case. If it's a cat or a dog, it'll say that the animal is a house pet, and it'll default saying that it's not a house pet if it's something else. So let's run this and let's see what happens. Okay, animal is a house pet. Let me put in here bird. Even though bird is a house pet, the way we've written our code, it should go with the default and say that animal is not a house pet. And we could add in here bird if we'd like, and we could change this to something else like a horse, not a house, but a horse, and see what happens. Okay, animal's not a house pet. I would think most of us would agree that a horse is not a house pet. So you could write it like this. So to write the equivalent if statement, we would have to write something like this: if string is equal to cat, or string is equal to dog, or string is equal to bird, that animal is a house pet. Else that animal is not a house pet. Okay, so let's see if I did everything right. I could have made a mistake. That's a possibility because I'm just doing it on the fly here. Okay, oh, yeah, it's right. I can't use an or. I got to use the double, what we call the pipe symbol. Sorry about that. I write in several different languages, and or is valid in a couple other languages that I use. So I'm sorry for that mistake. If you write in several languages, you'll probably do some of the same types of things. Okay, see, we got animals, not a house pet. So this switch statement is equivalent to this. This is probably a little easier to read. But there are cases to where you may want to write it similar to this, especially if you've got other variables that you're taking into consideration, stuff like that. More complex examples, it really just depends. So unless I tell you to write it as an if statement or as a switch, you can choose which one you want. Now, there may be cases to where, depending on how you write your code, that it may be more appropriate one way or the other, and I may take off for a little bit of that, depending on if you write the code the wrong way. But in a lot of the examples that we do in the assignment that I'm going to give, I'm actually going to have you write it both ways because I want you to see it written both ways. Okay, so a little assignment here would be for you to go through and make some adjustments on this and see what works and what doesn't work. Play around with it a little bit, maybe add another case statement here with something else. See what happens if you do something like this. Let's say case 1. Give us an error because this isn't a 1 is not a string. Yeah, exactly. So try different things and try to predict what's going to happen. You're not going to mess anything up. Worst case scenario, you just have to refresh your browser and go from there. Okay, another thing that's powerful about switch statements is that we can write, we can look at different ranges very efficiently. We can use a single case and a switch to match a range of values. Now you can do the same thing with an if. With every switch statement you could write it as an if statement. So you could do it either way. It's just that sometimes a switch is less typing, and so sometimes that is more appropriate. So let's look at this example. Let's get rid of this. And I think we had a let number equal to 20. Let me just verify that. Yeah. Okay, let me pretty this up. Like, see how this prints us like this, has this like this. And if you had other print statements, for example, or you had other statements there, maybe different variables, whatever, this doesn't look very good. It's kind of hard to see what's going on. With just 5-10 lines of code, it isn't real difficult, but if you start talking about hundreds of lines of code, this can cause a headache real quick. So make sure that whenever you write your code, you know, if you're seeing me indenting things, stuff like that, it means that you probably should be doing the same things as well. I will, on most assignments, I'll count off for stuff like that because that is important. Even though your code works right, it may produce the right results. That doesn't necessarily mean you're going to get all the points. You may get most of the points, but it is possible that I could take off if you don't write the code so it's pretty, so it looks nicer. Notice this is a little easier to read. We got our switch statement, then we indent for all of our case statements, and then we indent further for the statements that we're running for each of the cases. I like to put the cases on the next line. Put the statements on the next line. I think it just makes it easier to read that way. So I prefer that you guys try to do that too. Let's look at this example. We have a variable called number. We could be called anything, of course, and we're set at equal value of 20. So here's our switch number, and we look to see where our number would fall in any of these ranges. So we could have a set of ranges like what we have here, and this is 1 to 9. Since this is less than 10, it's referring to 1 to 9. So for this case, it's only a 0, so that's okay. We can switch between or have cases to where we have a 0 and then have another one to where we have a range. So this is just a single value and this is a range. That's perfectly fine to do. So since the number is not equal to 0, we jump down here. We check to see if the number is between 1 and 9. Number is not between 1 and 9, so we jump here. This is 10 to 19. since number is not in between there, we jump here. Since it is, this will print out between 20 and 30, and then it jumps out of the switch statement. So that's what we think it's going to do. Let's click on the run, and let's see what it's really going to do. Okay, that's exactly what it does between 20 and 30. Now, there's times that you'll go through here and you'll read code, and it may do something different than what you predict. If that's the case, then you need to go back and try to reread your code and try to figure out where you went wrong. Is there something wrong with the logic of the code that you wrote, or is there something wrong with the way you interpreted the code? It could be one or the other or both. And so you'll have to just take the time to do that. So I could say this is a 30 here, and what it should do is print out this, but if I'm in a real quick hurry, I may not see that this is less than 30. I may just glance at this and think, oh, this is going to print out between 20 and 30. And whenever I run this, I'm like, wait a minute, greater than 30 or less than 0. Well, actually, this should be greater than or equal to 30 or less than 0. So this print statement is actually not accurate for what is going on in the case. But that's beyond really what's going, that's not really what's important. What's important is to be able to read this and be able to go, oh, well, gee, this isn't going to execute here because this is really just 20 to 29. This would be equivalent to writing 20, 29. And notice the two dots. The two dots mean that it's a range. So it's 20 to 29. So this is equivalent to what we had before. And so if we execute this, it'll still print this down below. Did you mean, oh, it's actually 3 dots for the range? Notice that here we replace one of the dots with the less than sign. And so that's what's going on. So notice here I made a mistake. It's easy to do. And that's what the compiler is there for. It's a helper. It's supposed to help you write better code. So it's here, it's greater than 30 or less than 0. Even though I got 30 here, this is a range of 20 to 29. That is the same thing as writing this. I think it's better to write it like this than what was there before. But depending on what you're doing, it may be better to write it this way. It really just depends. So it really depends on each case what's the best way of doing it. And as you write code more, you'll get better at figuring out what's the best way of writing it. So let's carry on. Actually go through here, play around with this a little bit more. Notice like what I did where I changed this to 29. I noticed that we needed 3 dots there instead of 2. That's the best way to learn. We can extend this further in Swift by using a where statement in a case. So we can extend this out a little bit more. And instead of what this really does is this statement here checks to see if temperature is even. In other words, if it's 0, 2, 4, 8, 2, 4, 6, 8, 10, and none of the evens, none of the odd values. So let's look at an example. And of course, I'm going to go through here and like I do with all the other examples, make it look a little prettier. Okay. So what is this going to do? We got temperature is equal to 24. So case of 0 to 49, 24 does fall into this range. And then we also check to see where the temperature mod 2 is what that operator is. And really all that does is check to see if it's even or odd. And 24 is an even number. And so this case statement does then evaluate to true. And this is what will get printed, cold and even. So that's what we think is going to happen. Let's click on run. And that's what happens. Let's change this to an odd number. What's going to happen? I think it's not going to do any of these, and it's going to print this here. Now, you may think, okay, it's going to still print this. Well, let's see what happens. Since none of these are true, none of these case statements here are true, it's going to go with the default and say temperature is out of range or odd. If we go with something like 50, say warm and even. You could also write this as an if statement. So I'm not going to write it all, but I'm going to write enough that you could take it and notice how much more work this is. Temperature, right to me, temperature may be misspelled. Temperature, maybe not, I don't know. It just looks weird to me, right, for some reason right now. We could say if temperature is greater than or equal to 0 and temperature, no, that's right, is less than or equal to 49. Oops, and I'm using and whenever I should be using the double ands, double amperand. And temperature mod 2 is equal to 0. Print cold and even. We can have an else here for the others. And let me go ahead and do that. I can copy and paste that for a lot of that. Do that. Else. If notice how much more work this is, how much harder this is to read. This is a lot harder to read than what this is to read. So let me go up here and let me put in something. Well, let's just try 50. Well, I got to change these values again. That's 50 to 79. And then we got 80 to 110. And let me change this to warm, this to hot. And let's see what happens. It should print out the same thing. If I did everything right. Okay, warm and even. That's what we would expect, warm and even, and then warm and even down here. So these are equivalent statements, this and this. I still think that this is a little cleaner, a little bit easier to read. The ranges really help with that. This here really makes a huge difference versus this. Of course, you don't necessarily have to write it as a switch, but in this case, this is a little bit better than this. I might let this slide without really complaining a whole lot, but I may say, hey, maybe try this with a switch and see what it looks like. Let's try a couple other values. Here's Bobby. There you go. Thank you. Now let's try a couple different values. Something that'll work in this first case. Let's start with what we had before, 24. It should be cold and even. Okay, it is cold and even. And let's try something that will work up here with a hot. So let's try something hotter. Let's say 86. Hot and even. Okay, now let's try something that an odd number. Let's say 75. So by running these examples, of course, I could run a few more, but it looks like that this if statement is equivalent to this switch statement because we seem to be producing the same results, and then also because I can check here that these values are the same. Now, one thing that would be good to try would be some of these range cases here, like 0, things that are right here on these edges here, like 0, 49, 50, 79, 80, and 110, to make sure that the O's are producing the same results. And if they do, then these two statements probably are equivalent, as we can kind of see here. So I'll let you do that as an exercise to try different values to verify that these are the same. Okay. Okay, matching multiple values. We've kind of already done that with the where we've had like the dog and the cat with the string example. So I'm not going to go over this example. You can copy and paste this in and verify that this is producing the right result. One thing that Swift allows for is for you to be able to run more than one case statement. Where more than one value may be true in certain cases, to where you would fall through, or where you execute the first operation and then you do another operation. I'm not going to show you any examples of that, but I want you just to be aware that that is possible, to have it to where a value, where if it's true for this, where value is equal to 1, it executes this, and then it would then go ahead and execute case 2, even if it wasn't true, and so on. So it's able to execute more than one of these. But that's kind of beyond the scope of this lecture. The reason why I bring that up is because other languages like C, for example, the default is to execute the first one, and then you have to default with a break statement for it not to execute the ones below it. So Swift does something a little different, and so if you've already gone through a C-based language like C or C++, maybe PHP or something like that, if you've been introduced to switch statements, that is the default, is to automatically, once it executes one, to go ahead and execute other ones until it runs into a break statement. Like I said, that is a little bit beyond the scope of this class, and so I'm not going to spend a lot of time on it. I just want you to know that that is a possibility, and that is the default for most other languages. But for Swift, this is the way that it does it by default, is that it executes the first one that is true, and then it jumps out of the switch statement. Even if it is true for other cases or whatever, it does not execute any of the others. It will just jump out. Okay, I think that's about it.